All right, screen এই নিচে নোটেড কপি করে নাও আজকে I think I should start phases with you guys. Phase difference by difference. Oh, the CRO page. Do you guys have this diagram? I said I'll upload it. I think yesterday I uploaded it, so you can just go through it. I think diagram draw করতে time চলে যাবে. But basic idea যেটা ওটা তো আশা করি যা বুঝছো. It summarizes at the bottom as well. You count the number of boxes and you multiply with the time division. Okay, so that's how you find this. But এটা হচ্ছে কোনো জায়গায় ওটা properly দেওয়া নেই, so এই জিনিসটা কপি করা দরকার. Okay, so this is basically pulse duration, pulse length, and pulse intervals. I'll write what they mean on the side. Page 31 এর পাশে 31. I'm guessing everyone's exams are over. No, I mean physics. Practical. When is it? 5th. Oh, you have some time. 5th. Yeah, tell a Saturday day. Share your problems with Chava. There's 3 practicals you just have. Okay. All right, so let's start. Pulse duration to keep. Pulse duration hoche the time that a single pulse takes, or duration of a single pulse. Next is pulse interval, time between sending and receiving then pulse length is the pulse length. It's the size of the pulse in terms of wavelength.
Could you show the car going back analogy again?
Yeah, I'll draw that and show. And the y-axis represents your intensity. So that's your intensity of the wave sent, and this is intensity received. And it's lower because of energy loss. Is there any relation between pulse duration and pulse length? Yeah, I mean, if your duration is larger, your length will be longer. It's actually equals of lambda. So time যদি বাড়ে wavelength বেড়ে যাবে. What is intensity? Intensity আমাদের টপিক আসছে but just বলে রাখি it is the energy that a wave transmits. The blue part of the waves, so the wave and then this is the right term is incident wave, and this is the reflected wave. Are you guys done?
So if the x-axis has meters per second, centimeters per second, then we can say it's the pulse length.
If the no, this is it. What you need to know here is the frequency. When you want to figure out the pulse length, right? Speed equals to distance by time. Yeah, and you need to find distance, so you need to know the speed of the wave. So if you know the speed of the wave and if you multiply with the pulse duration, you'll find the length of it.
We'll find it for the same one.
Yeah. But the pulse length label here is not appropriate because the x-axis is not distance, right? So that's why. শেষ আচ্ছা একটু এদিকে practical example বলে কিভাবে question আসতে পারে so you mostly get these in paper 1 MCQs, okay, plenty of them. In fact, if you look at the MCQs I've provided, they're mostly this, okay, but once in a while you may get like a theory question. Last data ashlo eta tomদেরকে একটু বুঝাই, okay, so last question that came was a car backing up and the distance here was 40 centimeters from the wall, okay, and the car is here, and I think I mentioned this. Cars have this thing called like a collision detector, parking sensor, so it continuously keep waves into and the waves bounce back and they come back, and that allows the car to figure out how far the wall is, and at one point it gives you a sound, even stops itself, okay, so that's called a parking sensor. So এখন যেটা ছিল, they used a wave that was very big in size, something like that, and the problem with the wave that's longer wavelength than the gap, the pulse length is bigger than the gap itself. What is the problem that you have? The wave is not completely sent out, and as it hits the wall, it doesn't reflect properly. As a result, you don't get the full information out there. Basically, the idea is out there that the gap length, right, of whatever you're trying to measure must be bigger than your pulse length, or the other way around. The pulse should be smaller than the gap length. Do you understand what I'm trying to say? So আমার যদি এই রুমের হচ্ছে I'm going to use like a detector, some kind of sensor. I'll be moving towards the wall and it'll tell me when to stop. If you use radio waves are wavelength nothing borrow 10 meters, 15 meters, right? A distance, like where my hand is right now, I can take a wave pathale, the whole wave would be till the wall there. And as I start to go closer and closer, a wave taken to cut off হয়ে যাচ্ছে. And as it comes back, the information is not properly received because they're expecting full wave to come back. But এখানে কি আসছে? A partial wave. So what can I do to make my distance measurement more precise, and I can go much closer to the wall? What would I do? Very simple answer. Yeah, make a smaller wavelength. So আমি যদি হচ্ছে radio waves এর জায়গায় microwaves use করি, far better. Microwaves এর wavelength হচ্ছে যদি না জানো আমাদের জানতে হবে eventually, it's around 10 centimeters. So how close to the wall can I go? 10 centimeters minimum, okay? Because that's the size of the wavelength. A single pulse will show up, right? If I want to go even further, what can I use? Yeah, so more smaller wavelength, infrared, right? Visible light. Visible light doesn't work. Can anyone tell me why? Why can't they use visible light in only small wavelength? But why can't they use that as a sensing wavelength? So sensors, so mostly we use the microwaves most. Right, very good. So visible light is coming from everywhere else as well. So your car sensors will be overridden with the background light, বুঝবে না কোথা থেকে light আসছে, right? So generally যেটা use for example. Yes, so that's the point I was going to. What do we use actually for these sensors? Do we use microwaves, radio waves, infrared, visible light? All of them are present around us. Are there radio waves around us? Plenty, because of the towers, right? Is there microwaves out there? Horrifying, obviously. If you could see microwaves, right, you'd go blind right now. You know, there's so much microwave around us. Every router, every phone, every tower is screaming in microwaves. Okay, so satellite it's like full microwaves everywhere. So microwaves is not good because it'll basically interfere with your microwave. Okay, and that happens if you have routers nowadays. You'll find this 2.4 gigahertz and 5 gigahertz. The channel alada. Because 2.4 gigahertz is like what everyone uses, and there's so much noise out there that it reduces your speed. So now they're creating another channel, 5 gigahertz বলে ওইটাও নাকি fill up হয়ে যাচ্ছে. So eventually when you buy your router in the future, like 10 years from now, there'll be like 20 channels out there. যেকোনো একটা select করতে হবে. So there's less interference out there. Okay. Anyways, so ওইটাও কাজে দিচ্ছে না. Infrared problem কি? There's so much heat out there. Your car is in the parking, sun rises and it starts making noise because it thinks it's next to the wall, right? Because light falls on the sensor. So key use camera. X-rays. Ultraviolet. No. So yeah, we don't use electromagnetic waves at all. We use ultrasound. There's no ultrasound around us unless there's a bat flying by. That's how there's no ultrasound. So we use ultrasound for that purpose. Okay. So these are all ultrasonic sensors out there. Okay. Autonomous driving cars, the cars that drive themselves, or a key use for it. Sound, ultrasound, and nowadays they use light as well. Light to see. They literally see. Okay. Right. So the point I was trying to make was a length, right? And tomorrow wavelength your wavelength needs to be smaller. So an appropriate size here would be something like this, like that. So that's like a good size, okay? Because there are multiple waves out there, and that's like properly like detected by your sensor. That's fine. So the idea is again, the pulse length has to be smaller than the gap we want. There's one more thing that I need to mention: pulse duration and pulse interval. Eight and a basic question. Actually, last year I দেখেন বললাম, but pulse duration and pulse interval. Pulse duration মানে কি? The length of your pulse, মানে how long your pulse lasts, and pulse interval কি? The time between your pulse going and coming back. Okay, can you tell me if my pulse duration is longer than the pulse interval? What's the problem? I talked about this last class. They overlap. When I sound send করলাম, the way it works is like this. I send a sound and I stop, and the sound is going. It hits something, it comes back, and I receive it. Perfect. There's a proper gap, and the sound is not interfering. But let's say I'm making the sound বাজে যাচ্ছে এখনো as a pulse, and meanwhile যেটা গেল ওটা back করলো. So simultaneously, what am I doing? I'm sending the sound, and I'm expected to watch the sound as well, receive, because my length of the pulse is so long, it overlaps the interval. It's a problem, the device that makes the sound is the one also receiving the sound. It can't do both at once. It's called a transducer. So তখন যেটা হবে তুমি pulse send করে যাচ্ছ, pulse আসতেছে, but the detector doesn't detect them. Okay, so that's why we need to make sure the gap is large enough between your pulse and like how much time it takes for it to go and come back. Okay, right. So that is what we need to know here. But I mean, after disclaimer দিয়ে রাখি that I just gave you the fundamentals of it. ওই MCQ paper যে CRO questions will get better at this. Because the questions are very unique. They try to make it unique. Okay, so the past paper question will be easier. Also, in chapter 1 at MCQ, you can try them now. You should be able to answer all of them now. Okay. Less. Right. So higher frequency means more energy, and they compensate more energy with lower range, because the Wi-Fi router has a peak power rating. So তুমি power gigahertz বাড়ায় দাও, অনেক power consume হবে, So ওরা power rating টা same রাখার জন্য ওরা frequency বাড়ায় দেয় but range টা কমায় দেয়। Okay, let's move on. Can you go to page 33? Page 32 থেকে একটা জিনিস বলে রাখি, তোমরা মার্ক করে রাখো, এটা মনে রাখতে হবে, okay? The wave equation. I hope you remember it because otherwise you'll have trouble everywhere. Acha, you remember V equals F lambda? Okay. And I discussed this earlier, but I'm now just recap. We talked about this last week. V equals F lambda mode. Can you tell me which are the independent variables and which one is the dependent variable? V and F. And dependent? Wavelength. Right, correct. Okay, so just mone rakho, ekhane what can you change? V and what? F. What can't you change on its own? Wavelength. So wavelength is always a consequence of the other two. Okay, so আমি speed change korte parbo. How? Change in speed or variation in speed kemne ana jay? Change the, yes, correct, very good. Variation through change in medium or for water depth. Can you tell me how can I change my frequency? Yes, source. Okay, so source and wavelength is going to be changed because of what? V or F. Clear? So অনেক সময় যেটা হয়, they ask you some kind of relationship, the wavelength change হবে কেমনে, V and F there. So student অনেক সময় দেখে যে F and lambda মধ্যে চলে যায় বা V and F এর মধ্যে ইন্টারঅ্যাকশনটা দেখে যে স্পিড বাড়লে ফ্রিকোয়েন্সি বাড়বে। That's incorrect. Okay, স্পিড বাড়লে ফ্রিকোয়েন্সি বাড়ে না, স্পিড বাড়লে ওয়েভলেন্থ বাড়ে। ফ্রিকোয়েন্সি বাড়লে স্পিড চেঞ্জ হয় না, ফ্রিকোয়েন্সি বাড়লে ওয়েভলেন্থ কমে। More frequent waves would mean they're very closely packed. That's the smaller wavelengths. Okay. Done? Okay, let's move to a new topic. Interesting topic. Page 33 te jao. Also, I believe we're done with wave properties. Just আমি checklist টা করতেছি, তোমরা আমাকে বলে যদি কোনো কিছু না বুঝে থাকো, okay? Describe what is meant by wave motion, illustrated in ropes, pipes, and ripple tanks. I think I did all three of them. Understand and use the term displacement, amplitude, period, frequency, wavelength, and speed. I mean, আলাদা রাখছি because it's so important, it deserves its own chapter. So এটা পড়বো আমরা. So yeah, this is done. Understand the use of time base and Y gain of a CRO to determine frequency and amplitude. Y gain is basically which one? Voltage. Okay. Derive using definitions, speed, frequency, and wavelength of this. Eta all levels chilo, but I have done this in previous batches as well. Hit and miss. অনেকে মনে রাখে, সবাই মনে রাখে, অনেক সময় দেখা যায় সব কারোরই মনে নাই। এটা বলতেছি এখন। Understand energy transferred by progressive wave. Yeah, we have seen that from all levels. এই যে এটা এখন আমি করব, okay? So before that, এই যে V equals F lambda, কেউ আমাকে বলতে পারবে কেমনে derive করবা? I also want you to build the habit of deriving things. মানে সবকিছু derive করে দিলে যেটা প্রবলেম হয়, কিছু যদি মনেও না থাকে and you are capable of deriving, since you didn't memorize, you don't even try. বুঝছো কি মিন করতে চাচ্ছি, যে ওই students don't really understand the idea that they can derive themselves as well. They always feel like এটা করানোর কথা, I should have memorized this and then I derive it, right? So ওরা কিন্তু এখানে বলছে using equations of waves and speed and distance and everything, derive V equals F lambda. Right, online একজন লিখে ফেলছে অলরেডি। আমাকে বলো তো কি করবো আমি এখানে? Sorry, time. Which formula would you start with? Okay, I'll use that. Speed equals to distance by time. And what is the distance traveled? Lambda. Okay. And when you cover a distance of lambda, the time taken is known as what? The time taken is known as a time period, capital T, right? This can be written as lambda into what? Yeah, lambda into 1 by T, which is frequency, right? So there you have it. Okay. It took, I feel like, other করে করার কিছু নাই, but লিখে রাখলাম just for the sake of it. So এরকম অনেক derivations হচ্ছে A2 তে it's plenty, মানে there's something new every year, but once you build a habit of নিজেই পারবা, আর ভালো গাইডেন্স দেয় যে এটা ইউজ করো, এটা ইউজ করো, দুইটাকে কম্বাইন করে দেখো আনতে পারো নাকি। ওকে, okay, let's start. এখানে হচ্ছে intensity power by area and intensity is proportional to amplitude square, দুইটা প্রপার্টি শিখবো আজকে আমরা। So সবাই একটু এদিকে দেখো, let me explain this process and then I'll show you how to use the formula. So what is intensity? Intensity versus brightness versus power, three things. Okay, intensity, brightness and power. The problem is light could be intense, light could be bright, light could be powerful. They're not the same. They're very different, the three quantities out there. Okay, so intensity, brightness and power, clear about them? The three, we're going to define them. So when I look at this lamp and there's a light, there's a certain brightness or whatever you see, light, air, intensity, they're in English used as synonyms, right? Physics say two different. So when I look at this light, right, the light that falls onto my eye, is it its maximum peak brightness or I'm getting a lower version of it? মানে আমি যখন লাইটগুলো দেখি, is that the highest power more than what it's actually? Lower, right? কেন? Because I'll show you. তোমরা যখন কোশ্চেন না বুঝে থাকো, very basic একটা জিনিস. So if I put the light here, right? Like throw light, the light. So as I do this, is it the same নাকি কমে যাচ্ছে? কমে যাচ্ছে, right? I'll do further. Right. So is it there? Do you see the light? And as I do this, it goes to maximum, right? So what is happening? Is it the light that's reaching you changing, or is the light here changing? Yeah, I'm changing it, right? So what am I changing? The power, the brightness, or the intensity? No, power. Acha, আমার ফোনের মধ্যে there are different power settings. I'm giving different power settings, and এটার powerটা change হচ্ছে. Of course, you're seeing different, but that's because I'm making the change. কিন্তু look at this, okay? If I hold it onto the screen on the board here, you see the light on the board? So I'm যদি এখানে ধরি, do you really think that the light is visible? মানে এখানে light আছে একটা, so হালকা shadow পড়তেছে, but is it like very obvious? আচ্ছা, maybe you think it's obvious. Let me show you what will happen when I go closer. Isn't that much more obvious, right? But আমি কি power change করছে of the light? No, right? So, but it changes here. What is the factor that's affected it? This distance. No, I'm just asking what's the factor that affects it. So as I get closer, isn't it like that? As I get further, isn't it like less bright out there, right? So এখানে কিন্তু the independent variable is what? The distance. আর এখানে the independent variable is what? The power, right? So দুইটা জিনিস কিন্তু factor in করে, একটা হচ্ছে distance আর একটা হচ্ছে power. এই দুইটা জিনিস মিলে we have something called intensity. Intensity is what you receive eventually, okay? What are the factors that affect intensity? How far you are and how powerful the light is, right? So if I bring the light closer, same power again. So if I bring it closer, doesn't it get more intense, right? So it can key hoche. Am I changing the source? No, right? I'm only changing the distance. However, I can keep my distance fixed and I can vary the watt of my light intensity, right? So and I don't think you can see the light properly, but that doesn't it change? So yeah, these are the two factors, and when you're taking these two factors together, you have your intensity. So intensity formula হচ্ছে generic formula. Intensity is the power divided by the area. So this is area on which light falls. And this is the power of the source. And this I here is what we call intensity. Intensity unit ki guess korte parba? Power unit ki watts, right? And what is the unit for area? meter square. So what is the intensity unit? Watt per meter square. So it essentially tells you for 1 meter square, how much power will you be receiving? Surface area, না surface area হবে না, এটা একটা contact area বা যে এরিয়ার উপরে লাইট পড়ে ওইটা, so surface area একটু different হয়ে যায়. So how does light vary as you go further and further away from a source, right? We just established what does it do? It decreases. One of you asked the question, is this candela? So candela, I'm going to বলছিলাম তোমাকে, candela was removed from physics 2017 আর 19, okay? Candela কে remove করে এটা করা হয়েছে. And the reason behind that was candela was only applicable for this particular equation, which is kind of obsolete because এটা ছাড়া আর কোনো জায়গায় যেহেতু use হচ্ছে না, what's the point in having a unique unit for it? So they changed it to watt per meter square. Okay, rest of them to অনেক জায়গায় use হয়. Candela is only exclusively used for what? Intensity of light. So having a SI unit just dedicated for that is not appropriate. So anyways, what I'm asking you is how much is the power receiving you changing over distance? So let me explain the concept. Please carefully board দেখো. Students have said that they struggle with this. So you have a light source here, and a light source হচ্ছে, the further you go, light source are dimmer হতে থাকে. So we first have to establish why is it getting dimmer. So as it's going further and further, এটা dim হয়ে যাচ্ছে lightটা. I don't know if you can see it on the screen, but the further I go, it gets dimmer. What is the relationship? What is the way to find out how much dim it gets? So এটা বের করার জন্য there's an idea out there. It's called point source. So what's a point source? It's basically a omnidirectional light source. Do you know what it means by omnidirectional? It's mono হবে. Mono, yeah, every direction. Acha. So mono versus omni. Omni means everywhere. Okay, our mono means one single. So monochrome bole. Monochrome means one color. Okay, omni means everywhere. So you have a light source that's given light in every possible direction. In what manner? Perfect distribution. Okay, so our lamps they're not omnidirectional because the light is not going behind it, right? If you have a lamp, one of those tungsten lamps out there, what do you think the omnidirectional now? Is at the top, what do you have? The holder. Also inside you have the filament, and the filament only sends light sideways, not in all directions. So can you give me an example of a perfect omnidirectional object? Stars. Okay, the perfect omnidirectional object out there are stars. They radiate energy in which direction? Every single direction, almost equally. So once you take this, you find that there's this unique interaction. So as I keep going further and further away from the source, যে লাইটটা বের হচ্ছে, এই লাইটটা spread out হচ্ছে obviously, but it falls onto a shape, right? Can you tell me if you have an omnidirectional light source, like a point, right? And light is coming out from it in all direction, and it falls onto a surface. What surface is this light falling on? মানে আমার হচ্ছে এখান থেকে light বের হচ্ছে, right? And the light is going this way and that way and that way and that way everywhere, right? So it's spreading over a what surface? What shape surface? Sphere. Perfect. Okay, so at the spherical ball create another light. It's like going and falling everywhere. Is there a part that it doesn't fall onto? No, right? So if it covers every area around it, what is the area? The area of a sphere. Do you know what the area of a sphere is? 4/3 pi. Oh, that's not the formula. That's the volume. Yeah, 4 pi r square. Okay, so the area here is 4 pi. I can do distance to d hoy 4 pi d square. Okay, now look at this. Show my screen. I'll show you something important. If I were to be at a closer distance, not the distance d, let's say distance x, would the area have been larger or smaller? Smaller. Do you agree? মানে আমি যদি কাছে থাকতাম, wouldn't the sphere be a smaller ball, right? And if I went even further away, let's say এখানে হচ্ছে s, do you think the sphere would be larger or smaller? Larger, right? And since intensity generic equation is intensity is the power over an area, like power of star to change হচ্ছে না, key rather change হচ্ছে area, right? So as I keep going further and further away, right, what happens to the intensity of the light? Decreases, right? Reasonটা কি আমি একটু বুঝাই তোমাদেরকে, reasonটা interesting একটা জিনিস. When I have this lamp here, right now it's, let's say, 8 watts, okay, at a distance d, মানে 8 watts at a distance d. আমি যখন দূরে চলে যাচ্ছি লাইটস গুলো কিন্তু স্প্রেড আউট হচ্ছে এভাবে। So if you think of the rays coming out from a source, right? Do they come out in straight line or do they come out radially? Radially মানে কি? The lines are what to the surface of the structure, perpendicular. And that's the classic image of a what? Sun. You know, when children draw sun, they draw the rays. Rays গুলো কি এভাবে যায়? Not right. It's everywhere in every direction. So it's basically called radially. And radially যখন lights গুলো shift হয় or transfer হয়, they're falling on area. area. And intensity is how much light falls onto each area here, right? So if you look at this structure here, a same power is dissipated over a smaller area. So isn't the light more concentrated? Yeah, I was right here. Okay. Anyways, what happens is that concentration is more like how concentration works, right? Or how pressure works. Pressure is the force per unit area. So as the area gets bigger, right? Force changes. So what happens? The pressure increases. Why? The force is getting divided over a large area. My point. So if I have an even larger area, same force, then it's spread over a much larger area like that. So key point. Pressure কমে যায়, right? Similar things are happening here. So eventually what we find is the formula for intensity at a distance. So intensity at a distance is equal to power divided by area. And what's the area that the light is spreading onto? The surface area of a what? Surface area of sphere. Equation দিব এখন ওটিকে মনে রাখতে হবে, this is the background of it, আছে ক্যাট করতেছে এটা. So intensity is eventually equal to what? Intensity is equal to power divided by what was the area? 4 pi d square. And this is a very handy equation. It tells you how power changes depending on how far you are. Okay. Now students have argument that this light is not a point source. It isn't, right? But can I use this formula here? Yes. কেন বলি যেখান থেকে লাইটটা বের হচ্ছে ওর কি জানা দরকার পিছে লাইট যাচ্ছে নাকি? No, right? It'll just function the way it is in the front, right? So these are all at different points, like point sources, the way the light is coming out. The only difference is the light is not coming out in what area overall, a sphere. So it is just straight a point থেকে বের হচ্ছে. So the ratio is still the same. The relationship is still the same. Okay. And yeah, it is I equals to 4 pi d square. And there's this link here, which is intensity is proportional to 1 by d square. And I really hope you know what it means. There's a name for this relationship. What is it? What was it? Yeah, TS. Okay, so the inversely proportional actually not. Sorry, no, it's not. Inversely proportional is something else. This has a very good name for it. And you maybe haven't heard it yet. A levels A2 is like everywhere. It's called the inverse squared law. Inverse squared law মানে হচ্ছে every time you increase your distance, the other quantity decreases by a what factor? A square factor, right? So আমি distance double করি, আমার intensity কত কমবে? 4 times. Triple করি 9 times. So if I increase my distance 5 times, right, the light almost disappears. You know, what is the decrease in the intensity? 25, right? And you can see it here. I mean, যেটা দেখাচ্ছিলাম তোমাদেরকে, if I place it here, right, yeah, that's like some distance, right? It's barely there. কিছু বোঝা যাচ্ছে না. But I come halfway is quite prominent. And if I go halfway of that, it's very bright. You know, the closer you get, it increases also what? Exponentially. Just the way it decreases exponentially. So this idea is called the inverse squared law. Our inverse law key, I is proportional to 1 by d. That's it. So this is called the inverse squared law.
So intensity is just that concentration.
Yes, it is actually. হ্যাঁ, because তুমি যত দূরে যাচ্ছ লাইটটা নিয়ে, the light is spreading out over a larger area. So every single segment of that area now receives less light. কারণ lighter amount same, but you're spreading over a larger area. Correct? হ্যাঁ, ওইটা এখন বলবো। Okay, so we did intensity, we have done power. Power is basically what it actually is given. Intensity is what you're receiving. What is brightness? Brightness কি তাহলে? Intensity is what I'm receiving, right? Power is what it's supposed to give out, which changes as you go further and further away. So what is brightness? Huh? Power. Power of the source or power you receive? Power of source. Achha, so the correct answer is it's both. And that's why in science, it is not considered to be an appropriate unit. Brightness to eta hote hobe. I'm bully. If I see a star and I say it's a bright star, right? And the thing is, it probably isn't a bright star. It is just a dim star, which is what? Very close to us. So the brightness is subjective. But when you talk about intensity and if you talk about power, it's very clear. If I tell you the power of something is 400 watts, what does that mean? What it actually gives. And if I tell you the intensity is 200 watts per meter square, what does that mean? How much I receive. But brightness there kono rokom meaning nai. Brightness could be what you see, brightness could be what you receive, brightness could be also what it is. Like TV the brightness থাকে, that is actually, you know, when you're setting the brightness in your TV, right? Or screen the brightness change on your phone, that's the power. আবার তুমি আর্থে দেখে বসে একটা স্টারকে দেখে বলতেছো it's a bright star. That's not the power. What are you looking at? The intensity. So brightness word আমরা কোনদিন ইউজ করব না. So I just kept it there because students use brightness and eventually দেখা যায় যে it doesn't really imply what they're trying to mean. Okay? Do we have brightness anywhere in physics? No. যেমন স্টারের brightness বলে একটা term use করা হয়. It is actually called luminosity. So yeah, the word brightness is not actually useful. Okay, so never use brightness to explain your answer. Intensity, power, these two. Okay. Right, so there you go. I'll add some notes here. এখানে আমরা একটা math করব. এই mathটা করলে you'll get a better feel of what's happening. Lumens is a measure of intensity. So তিনটা ওয়েতে intensity measure করা যায়. একটা হচ্ছে watt per meter square, একটা হচ্ছে lumens, আর একটা হচ্ছে projector use করে. Projector lumens use করে. Nits আর একটা nits হচ্ছে screener brightness এর জন্য use করে. So if you want to copy এই যে জিনিসটা দিব এটা কপি করা। আচ্ছা ওটা আমি জাস্ট বুঝানোর জন্য প্রোভাইড করেছি তোমাদেরকে কপিতে। পরের পেজে I need to do a math. ওই ম্যাথ হয়ে গেলে এই টপিকের হাফ হয়ে যাবে আর পরের ক্লাসে উইল ডু দ্য হাফ। ইন্টেন্সিটির জন্য না, ওটা হচ্ছে পাওয়ার। ইটস আ মেজার অফ পাওয়ার, কারণ তুমি ডাইরেক্টলি স্ক্রিন থেকে দেখতেছো, সো এটা সোর্সের পাওয়ারটা। না, লুমেন্স অ্যাকচুয়ালি ইন্টেন্সিটি, কারণ লুমেন্স হচ্ছে হলো স্ক্রিনে করতে পড়ে, or একটা particular distance কে reference ধরে tells you how much brightness is there or how much intensity is there. Bulbs এর হচ্ছে power nits বলতে পারো, because it's let's say it's an 8 watt lamp, right? এটা কি 8 watt আমার কাছে আসে নাকি 8 watt দিচ্ছে? হ্যাঁ, so that's like nits এর মতো। না, it's power related. Lumens হচ্ছে value per meter square এর মতো। Their unit থেকে তারা nits হচ্ছে how much the brightness or power of a device is per pixel. 1700 per pixel, 700 watts per pixel. That will like the sun.
I have no idea.
Wait, you're asking me what's the unit of the brightness of a screen? Nits. Power. P equals to VI. So for a student in O level, they wouldn't really understand what intensity would be. That's why they used to say brightness. So that's basically increasing the power.
They could add these topics in order to get a revision. They could,
Yeah, of course. They do.
but then they. Is the dissipation in loss?
Spread. Moon absorbs some of the intensity of the sun and re-emits the remaining intensity. Is that the right term? No, you can't emit intensity. Your statement is fine. The moon absorbs some of the power of the sun and re-emits the remaining power. And that power changes as it reaches you. So that's the intensity variation. Basically waves are energy carriers. They hit a surface. Part of it gets taken out by the molecules, so the molecules gain K and they become warm and whatnot. And some of them are reflected back. So every surface in this room is reflecting light, but it's also absorbing part of it. And whether it's a good absorber or not depends on the material type. So if you remember from your O level, dark, dull, and rough surfaces, they'll absorb more. Light, shiny surfaces will reflect more. So that's like the color, texture. These are the factors.
When an object absorbs light, what's the light being turned into?
So like turn into in the object, internal energy, the energy of the molecules in terms of K and P. Are you guys having schools in the morning regularly? Online classes, like regular timing. Wednesdays and Thursdays are off. And do you have an idea if it's going to be like this, or was it only for the exams? It'll be just like this. I'll be taking some classes in the morning, maybe 1 or 2 maximum. Okay, is I need to wrap up majority of waves by 15th December. So ওটা করার জন্য যতগুলো ক্লাস নিতে হবে আমি নিব. I feel like 2 extra classes would be enough. Okay, so it'll be in the morning. কোনো একটা morning, I'll let you know. No, just offline. Sorry, just online. Just online. I mean, my other batch students are doing simultaneously with school. Online school হচ্ছে ওরা আমারটা করতে পারে না, how they do it. Yeah. They just log in. Both they just log in into some device that doesn't have anything. We can রেখে দেয় আর আমার class করে. আচ্ছা, কোথায় যায় না? There's a question. Questionটা at least দেখে না. আমরা next class হচ্ছে solve করব. I know there's not enough time to actually solve it here, but because I want you to understand what the challenge is in this topic. Otherwise, that's it, right? So I don't want you to underestimate the chapter. So this is one of the more challenging ones out there. So দেখো কি হচ্ছে এখানে। আচ্ছা সবাই একটু স্ক্রিনে let me explain this question number next class is solved but next class I want to do something else. There's another intensity formula out there. So do you see here a power of 100 watt? So imagine this lamp is 100 watt, okay? And you are right now placing an object at the bottom there, which is 5 meters from the source. So first question for you, okay? Do you think that yellow shaded area at the bottom receives 100 watts? No, right? Why?
Because it's part of the source.
Correct, but I want like a more basic answer. যে কেন আমার 100 watt এখানে আসতেছে না? I understand your logic, but কেন আসছে না? Yeah, the 100 watt is spreading out everywhere, and you're only somewhere in the middle, right? So will you receive all the 100 watt? Think of like a source that's spraying water out. Sprinkler, a garden sprinkler, water is going everywhere, and you're standing with a glass somewhere. Will you get all the water in the glass? No, right? Similar thing. It's basically light catch cortisol, right? So yeah, it's that part there. But that part could be bigger or smaller as well, right? আমার এটা কি 10 by 8 centimeters না? এটা একটু যদি বড় হতো, wouldn't I receive more energy? আর একটু ছোট হলে কম হবে? So there are two factors affecting my energy achieved. What are those two? Area and the other one? Distance. Okay, so এইটা কেমনে solve করতে হয় is a confusion. এখানে formula দুইটা use করতে হয়. I've given you two formulas of intensity. Intensity equals to power by area, and the intensity equals to power by 4 pi d square. Students sometimes don't know which one is applicable where. ওইটা বোঝানোর জন্য this is the question we have. You can give it a try, but next class, first thing we'll do this.